Okay, right. The last part of the higher transformations of graphs is really to look at what is more likely to be asked of you at exam level. So in an exam, it is very unlikely they would just ask you to carry out one transformation. It's likely to be it's likely to be two, maybe even three transformations. Three tends to be quite rare, but it's not impossible for them to ask that. Really, it's more common to be asked to carry out two transformations. And to do that, it's very simple. It's just a case of taking one transformation at a time and then actioning that. So the first thing we're going to look at is the graph of y is equal to f of negative x plus 2. So over on the right here we have the graph of y is equal to f of x, and it's going through minus 3, 0, minus 2, minus 4, 0, 0, 1, 1 and 2, 0. And I want to sketch the graph of f of negative x plus 2. So I think the best thing to do always is to write down the coordinates that you have first of all. So our coordinates are minus 3, 0, minus 2, minus 4, 0, 0, 1, 1, and 2, 0. And wherever these coordinates end up, I must show where the transformation has led them to. So the first thing that I should really do here is the flip, the f of negative x. So if you ever have a flip in place, first of all, it's always good to do that first and then do any other transformations. So f of negative x, the negative is inside the bracket. So remember, that means we're going to take our x values and flip them, but we're going to keep the y values the same. So minus 3, 0 goes to 3, 0. Minus 2, minus 4 goes to 2, minus 4. 0, 0 stays as 0, 0. 1, 1 goes to minus 1, 1. And 2, 0 goes to minus 2, 0. Then the next transformation we're going to do is, from that flip, we're then going to add 2 to it. So we're going to move the graph vertically by 2. It's outside the bracket, so it's going to affect the y. We keep x the same. So I'm going to now add 2 to each of these coordinates. And that will give me the final graph. So 3, 0 will go to 3, 2. 2 minus 4 goes to 2 minus 2. 0, 0 goes to 0, 2. Minus 1, 1 goes to minus 1, 3. And minus 2, 0 goes to minus 2, 2. So let's go ahead and start to plot these. So minus 3, 0 has went to positive 3, 2. Which I'm going to say is about here. Now, minus 2, minus 4 was a minimum turning point. That has flipped horizontally, so it stays as a minimum turning point at 2 minus 4. It then goes up to 2 minus 2, which I'm going to say is approximately here. 0, 0 stays as 0, 0 for the flip, but then because we are then moving it up 2 places, 0, 0 is going to become 0, 2. 1, 1 stays, flips over to become minus 1, 1, and then it goes to minus 1, 3 when we move it up. So it stays as a maximum turning point and goes up to minus 1, 3. and 2, 0 stays, flips over to become minus 2, 0, and then it goes up 2 places to become minus 2, 2. So that's going to be approximately here. So that means that we have a graph that looks approximately something like this. Remember, graph drawing is not my forte, so apologies for the messiness of that. So that's what it's going to look like. The question has asked us to sketch on this separate diagram. So a good idea, if you ever get this situation and they ask you to draw in a separate diagram, I always still think making a light annotation on the graph that you have, just to show where the transformation goes to, and then copy it over into the separate diagram. So we have minus 1, 3 was the maximum turning point. We had minus 2, 2 was a point here. We have 0, 2 is a point here. We have 2 minus 2 is a point here. And we have 3, 2 is a point here. So again, that's a graph that looks something like so. And that is what I'm going to represent as my final graph. That is a graph of y is equal to f of negative x plus 2. If I was doing this in an exam and I annotated this graph here, you would have a separate blank graph on your answer booklet anyway, so don't worry about having on here. Use the graph they give you as a diagram to help you annotate it, but make sure you copy it over into the graph that they want you to put it onto. Right, okay, now we've done that, let's look at the next one. And this one we are going to do in blue. So this is the rare occurrence where we have 3 transformations going on. We have the transformation of a vertical flip with the negative. We have a multiplier of a half, which is going to compress the graph, and the graph is also shifting 1 place to the left with the +1 inside. And I'm going to do this in blue. So again, let's write down the coordinates. So we have minus 3, 0. We have minus 2, minus 4. 0, 0. 1, 1. And 2, 0. Okay, so it's always good to start with your flip first of all. So minus 3, 0 is going to flip vertically because the negative is outside the bracket, it affects the y. So minus 3, 0 stays as minus 3, 0. Minus 2, minus 4 is going to flip and become minus 2, positive 4. 0, 0 stays the same as 0, 0. 1, 1 flips to become 1, minus 1. And 2, 0 stays as 2, 0. The next thing we're going to do is we're going to half all of the y values, because the half is outside the bracket, and when a number's outside the bracket, it affects the y only. So minus 3, 0 stays as minus 3, 0. Minus 2, 4 would be minus 2, 2. 0, 0 stays as 0, 0. 1 minus 1 becomes 1 minus a half. And 2, 0 stays as 2, 0. And then the last transformation is to move the graph 1 place to the left. So the +1 is inside the bracket, Remember, when we have the number inside the bracket, we do the opposite. So instead of plus 1 to the x's, we're going to take away 1. So minus 3, 0 becomes minus 4, 0. Minus 2, 2 becomes minus 3, 2. 0, 0 becomes minus 1, 0. 1 negative a half becomes 0 negative a half. And 2, 0 becomes 1, 0. So let's have a look and see what that looks like on this graph here then. So minus 3, 0 really becomes minus 4, 0. Minus 2, minus 4. Now that was a minimum turning point. That flipped to become a maximum turning point. It then shrunk down with the half and then shifted along. So that is now a maximum turning point at minus 3, 2. I'm going to put my little maximum arc in there to remind me. 0, 0 stayed at 0, 0 for the flip and the half, and then went to become minus 1, 0. 1, 1 was a maximum. It flipped to become a minimum. It compressed up slightly and then moved to the left. So that's going to be a minimum turning point at 0, negative a half. And finally 2, 0 stays as 2, 0 for the flip and the half, but then goes to 1, 0. Okay, so that's, let me just put my little minimum arc in there to remind me. So that's a graph that's going to look something like, I'll start that again. It's going to look something like this. So now let me just take this down to the graph below. So minus 4, 0 is here. Minus 3, 2 is here. Minus 1, 0 is here. 0 minus a half is here. And 1, 0 is here. So that is going to look something like this. And that is all that's to it in terms of graph transformations. As long as you follow the 6 rules that we laid out there, and you remember the key principle of, if the number is outside the bracket, it affects the x. If it's, sorry, let me re-say that. If the number is outside the bracket, it affects the y. The x value stays the same. If the number is inside the bracket, it affects the x value, and it does the opposite effect. And that's all that's to it in terms of graph transformations. Let me just write in, this is the graph of negative a half f of x plus 1.